start the recording here and we'll get started. So chapter 8, OSPF. Now this is single area. We'll talk about what multi-area OSPF is and then some of the tweaks you can do to OSPF, similar to what you can do with EIGRP. Now every router needs some type of routing information. And you know, either you use RIP, which you learned in Cisco 2, and you enter in RIP, and then you put in the networks that it's connected to. EIGRP is the same thing. You enable EIGRP, and then you list the networks that are connected to it. OSPF, same or similar type of format as well. And so, kind of very similar philosophy. It's another type of routing protocol, or you can do static routes, right? Which is not a dynamic routing protocol. But routers need to be able to get from one network to another, we need to have some type of routing protocol. OSPF is open, which means it is available on non-Cisco devices. So if you're working in a mixed environment, this is what you would probably be using, OSPF, and that's why I test for it. Anyway, so what is OSPF? Well, it's a routing protocol, very similar to EIGRP, does the same thing, uses some different terminology to do very similar things. And when we get to multi-area OSPF, that's done a little bit differently, but mostly just conceptually, and it's not too hard of a concept to pick up. So there is, this is an example of a single area OSPF. So doesn't matter how the router is connected, whether it's through serial or through Ethernet or fiber, it all works. There is usually, the first area that's always set up is called the backbone area. It's always identified as area 0. So if you're just doing a one single area OSPF, usually just within the backbone here in area 0. There's something called a multi-area OSPF, which we'll talk about in chapter 9. But this is the way you'll want to usually design your networks when you have several routers as part of your topology. You'll notice that area 0 is the backbone. Everything needs to be connected to area 0, and we'll talk more about that when we cover chapter 9. But it's able to connect multiple areas together. One thing you do need to be aware of is that you do have what's called an area border router with OSPF. So that is a router 1 and 2 are called area border routers, or ABRs, and that's because they sit on the border between two areas. Router 1 is part of area 1 and area 0, and router 2 is part of area 0 and area 51. Get it? Area 51? Right. So just be aware of that. These are special routers that connect to each other and share the topology of each area with each other, which we'll get a little bit more into. All right, there are 2 versions of OSPF. Version 2 is the latest version, or the current version for IPv4. So OSPF version 2 is for IP version 4, and OSPF version 3 is for IPv6. All right, that's the only difference between the two. Your labs, the final, is only going to be dealing with IPv4, so I'm going to only be talking about OSPF version 2. All right, so in a single area, this is area 1, area 0 again, this is the backbone area. And as you can see, we have 3 routers that are here, right? We don't have anything that's an area router, an ABR at all. But when you're in a single area like this, one of the routers need to be designated as the designated router, the router that's in charge of OSPF. That's usually done by giving a router ID. The lower the number, that's the one that's the designated router. And usually there's a hierarchy. So if one router goes out, the next router that has the next lowest router ID is put in charge. You can manually put in a router ID, or you can let it automatically designate the designated router, which is usually based upon the MAC address of the router. So, but we're going to be putting in the router ID so that we can designate which router is going to be the designated router, kind of the router in charge of what's happening. All right, that's pretty much it, guys. That's kind of chapter 8 in a nutshell. There's a lot of history and concepts behind OSPF and some of this routing protocols, which I'll leave to you guys. There's also an algorithm that it comes up with, which I'll talk a little bit in chapter 9, which designates which route is the best route to go. That is, I believe it's SPF, which is the algorithm which calculates which path is the rest, and that calculates a certain number for a particular route. Anyway, so you can read more about that if you want to know more about that. All right. Let's get to chapter 9 and 10. There we go. So a few special terms to do with OSPF that I want you to be aware of, particularly with a multi-area OSPF. You can think of an area similar to like an AS with EIGRP. Remember, you have to have an AS number, autonomous system. Instead of autonomous system, they use areas, and the areas have to be designed with an area 0 as part of it. LSA is the communication protocol or communication updates that are sent from router to router. So that's how it shares information, is with LSA updates, and those happen at a set amount of time that they're transmitted with each other. And what they actually transmit is something called an LSDB, which is the topology, the network topology information, or the database for the topology. So for router 6 right here, that's in area 2, it has a topology layout of all the networks that are attached to it. I know we don't see anything attached to it, but let's say there's several networks attached to that one. And it will, and that's in a database. It's in a flat file, a file that's sent, but it will send an LSA and transfer over the LSDB to the other router. So now that router 4 knows what's going on with router 6, right? It's just the term for its communication and the topology database that OSPF uses, okay? Now we talked about area border routers, which are these ones that are, that share areas, right? So that's another terminology, abbreviate ABR, but there's also called this ASBR, right? Which is Autonomous System Boundary Router. This is the one that's usually connected to the ISP and out to the internet, right? So everything else is in your internal organization, and then you always have one router which kind of straddles area 0 and then goes out. This is also your default route out to the internet. So we'll also be configuring our default route out so that even though you're on a network connected to router 5, it needs to know how to get out to the internet, because it can get really confusing with all these other routers, which way to go. So you can tell router 5, yep, this is the way to go out to the internet. So we'll be setting that up as well. But the router that gets you out is the ASBR, just to cover some of the terminology. And remember, within each area, there is also a designated router, which is the router in charge, where you put a router ID as part of it. Okay. So here's the single area router and how they communicate. Now, the reason you want to break up OSPF into these different areas is to save on bandwidth and to conserve processing power within the routers. The algorithm that's used, the SPF algorithm that is calculated, uses a lot of CPU usage to calculate the best route out, to be able to read those LSDB tables, those networking topology database tables that the router has to use. And if those messages are constantly being sent, and it's being sent from dozens or hundreds of routers all to one designated router, that can cause a lot of overload for that router in and of itself, and use a lot of its resources, and it can be overloaded. So that is why we break that up. You want to group areas into reasonable sizes of groups, because every single router is going to be sending all of these messages, those LSBs, and be sending those LSDB database topology tables to each one of these routers. So if we can divide that up, that helps out quite a bit. So for instance, area 51 is only communicating with router 2. So yeah, all of these 5 routers are communicating with each other. Router 2 will then communicate with router 1 whenever it needs that information, and update that. And then router 1 is keeping track of everything in router 1 or area 1, and keeping track of all the information that's being passed over and all those topologies and everything else. And then anytime anything needs to go from area 1 to area 151, router 1 and router 2 handle that communication back and forth between the two. So it's just a way of divvying up the work and separating out the work that each of these routers have to do. So that's why we want to break these up. Some other benefits of it, let me see, I think I covered most of them. It's the algorithm doesn't have to run as often, using less resources. The backbone, or the main area, area 0, shares information with each other here, but doesn't constantly get the updates from the other areas. You get smaller routing tables. It reduces the frequency of these calculations, and thus saving resources. Now, when it does build up these calculations, it generates a number, which is called a cost number, which we're going to be manipulating a little bit too here in chapter 10. A cost number is just a set number for a privileged, or to identify the best path, right? So you have the SPF algorithm, which goes through and calculates the best path, and then that best path is given a number based upon bandwidth and its other calculation and everything else. And if it's a premier path, the lower the number, the better. So a really good path, the best path, will be given a number 1 cost, if that makes sense. A really bad path may be given a cost of 800 or something like that, right? And then there's costs of in between, right? And obviously, the traffic will always prefer and go to the one with the best cost. Now, if there's congestion that happens, or a line goes down, or something else, then it reroutes it. It works its way back up to the next best route and the next best route and everything else. So that's a cost number, but we can manually tell these routers some of these costs and be able to change that cost number if we wanted to, just because we can, because we're in control of the network as the system administrator, right? So some of the things that we can tweak on OSPF are going to be similar things that we can tweak in EIGRP. So we can tweak bandwidth, we can tweak cost, which you'll do in Lab 10, and we set up the default route. So the default route is always that router that's connected out to the internet, which I think a concept you guys should be familiar with by now. And that's pretty much it, guys. Let's kind of jump into the lab and see what we're doing. So I'm going to cover a portion of Lab 9. So this is Lab 9, which gives you a multi-area OSPF. Now, which is done very similar, and it's a little bit more complex than a single area. A single area, you're just dealing with area 0, which is what your lab for Lab 8 is. And you're just kind of repeating the process. So I thought I would just jump to the lab here for chapter 9, because you're kind of doing the same thing. And in chapter 10, you get to do OSPF again, but then you're tweaking some of the parameters of OSPF. So I'm just going to jump you right into the multi-area OSPF, right? So I have my router. I have it connected. Let me make sure I have my terminal connected here. There it is. I think I'm going to have to make it bigger for you guys. Make it big enough so you guys can see it there. Can you guys see that? That should be pretty big. Yeah. So I've already taken care of all the IP addresses and the addressing and everything else. So the first thing I'm going to do, and I've created these logical networks right here, and I've created this kind of fake internet out here to the logical internet, and that's where we're going to do the default route out to, right? And again, I don't have 3 routers, so I only have this set up between router 1, router 2. I did do this logical network here, logical loopback 6, but obviously I don't have this serial connection to router 3 set up. But it's all done the same thing. You're just creating it in a different area, area 3, the same way you set it up with area 1 and area 0, right? You're just kind of repeating the process. So let's get into this here. All right, the first thing we need to do is get into global configuration mode, as we normally do. And we're going to do just like most of the routing protocols, right? You did this with RIP, you do this with EIGRP, you do the router command, right? You do router RIP, you do router EIGRP, and now you're doing router OSPF, and you need to give it a process number. And that's what we're doing there. You can run multiple instances of OSPF if you want. And that's what that 1 stands for. So that number is arbitrary as long as you're doing it the same on all the other routers, right? Then what we're going to do, oops, I'm in router 2. I want to be on router 1. Sorry, let me go back here. All right, so I'm going to do the router OSPF 1. This helps enable it. Then what we're going to do is we're going to designate router 1 with a router ID because we want this one to be the designated router. So I'm going to do that. You do the router ID command, and we're going to give it a router ID. It looks like an IP address, and that's what we're going to designate it. Router 2, if you want your secondary or backup designated router, you would go in. So router 2, we might set the router ID as 2.2.2.2 or whatever. And that will be our secondary designated router in case this one ever goes down. All right, so now that we are in the router configuration, now we have to configure the networks, right? Just like you do with RIP, just like you do with the EIGRP, every router has to have a routing protocol if you want to network from one network to another, right? So let's look at these networks. What networks do we have connected here? So router 1 has this network, which we're not going to do. We're just concerned about the local one because that's the one out, right? But I want to configure this one, and this one here, all right, which is our serial connection. So the first one we had was 192.168.1.0. You do use the wildcard number as similar as we did with RIP. Oops. And this is where you designate the area. So this is a little different, right? This is the different for OSPF. So if we're looking at, I'm setting up the 1 network right here, which is in loopback 1, which is in area 1 in our topology there. So that's why I put area 1 there, right? Just gonna hit the up arrow. I'm gonna do the 2 network, right? As the 2 network, where's that located at? The 2 network is LO2, which is in area 1 as well. So I can just hit enter there for that. And then we have the 12 network, right? we have this 12 network, which is our serial connection, and that's actually in 0 or area 0, right? So we just have to do that. Just put a 1 there, right? And we have that. Great. All right. The other thing, and very similar to what we do with EIGRP and RIP as well, is we want to set up passive interfaces. Remember what the passive interface is? The passive interface is these routers are constantly communicating OSPF through all the networks to try and read what's in the network and everything else so they can build this topology table. The passive interface is what we're going to put here. We're going to assume that LO1 is connected to a switch and to multiple other PCs or devices. Same thing with this logical loopback 2 is a passive interface. So 6, right? That just goes to a switch, we'll assume, to other PCs and everything else. We don't want the OSPF communications to go out to these interfaces. So we will make them passive so that those LSB communications are not going down those networks there. They're only being sent between the routers, right? Because we don't have any other routers in router 1, right? So we want these interfaces that are only connected to switches and PCs to be passive and not constantly be sending that communication out. So that's what we're going to do. We're going to do passive. And we've done this with other protocols that we've used. Passive interface. And we're going to do it through LO1. And we're going to do it for 2. Right? And that's it. Exit it out. Then we want to set up our IP, our default route out, right? So our default route out. So we'll do IP route. Now, it's all right. We'll double check here. Yep. LO0. So we want this to be our default route out, right? So we use the all zeros that we normally use. That's all right. We got that. Oh, well, what we need to do now is we need to do the router OSPF, which you could have done in the first place. But remember, you have to do the default information originate, which we've done before as well. And then we should be good. Let's verify this, that this is set up correctly. And we will have to set this, a similar setup on router 2 as well. So how to verify this, particularly for your lab reports, right? I like to see the verification. So you can just do IP protocols. And if you look through here, right, it's self-aware with IP protocol, OSPF1, that shows me that we have set up one instance of OSPF, the first instance, right? We have a router ID that's part of that. Is it an area? It is an area border router, autonomous system boundary router, right? So it's both, right? It's an ABR router because it's between area 0 and area 1, and it's the ASBR, the one that's connected to the internet as well, right? These ones will not be ASBR because they're not. But this one will be a border router, ABR, but router 3 will not be because it's not sharing 2 areas between area 0 and the other area, right? So when you run this command, that's what you should be looking for in this description, right? That it all makes sense. This is an area border router, autonomous system boundary router as well, right? It has 4 paths. Here are the networks that it's connected to and what areas they're connected to. And here are your passive interfaces. Everything we just configured, right? It's all right there for you. And that, so you can verify and troubleshoot, make sure you did it right. We can also do show IP OSPF, which I don't think will show us because we haven't set it up on another router. Yeah, the neighbor, yep, there's nothing there because we haven't set it up on router 2 yet. All right, so let's go set everything up on router 2, which I don't think I did. Let's see. All right. So we're going to give this a router ID. We're going to give it network. And what network is router 2? So we need to have the 6 network, right? Sure, I got that right. I don't have notes on this one, so let's go back and forth more often. And that 6 network is in area 3. There we go. Then we're going to do the serial connection 12, right? Oh, and I think I messed up on router 1. I see that. My wildcard was wrong. So we'll do this. This is 0. Actually, that should be 3 because this is a 525. Yeah. So we may have some problems. Let's see. It's our 12 network. All right. Should see OSPF. It's starting to connect. It should start communicating. Although I think I need to go back to router 1. I don't think I did that correctly. Router 1. But let's exit here. Let's look at the information again on this. Oh, just IP protocols. What we got there, we have OSPF, router ID, should be an area router, just an area border router. That's it, right? Because it's not connected directly to the internet. There are networks that are tied to it. And I need to go back and check, make sure I did router 1 correctly here. Look at that, I did not. All right, so I need to go fix that. That's what happens when you reuse commands like I did, just by hitting the up arrow using the history. Maybe using the right. Yeah, it is all 1 and 2. All right, let's check this out. Let's make sure we can do this. Let's make sure we got it fixed. Oh, we have both, so I have to remove that one. Well, I can go back and remove it later. Anyway, let's see if we can see the neighbors now. Hopefully I didn't mess it up too much. Hey, we got router 2. We can see this. We didn't see that last time, right? And it's through that address right there, right? And there's actually more, a little bit more information right there. But I just have the font up so big. So you should be able to see the other router, be able to identify the other router in some networks. Let's see, we should be able to routes. So if you show your routing table here, you should be able to have an O there, which should be OSPF. And show you that we have a connection here. So through OSPF, this is router 1, remember? Router 1 is not connected to the 6 network. How did router 1 know about this network right here? It's through OSPF. That's how it knows how to route to that network. Now it knows how to get there if it needs to get there, right? It knows it needs to send it out through the 12 network, which is our serial connection right here. This is our 12 network, right? Right through area 0. If it wants to get here to our 6 network that's over here, just like that. And that's what OSPF does. That's pretty cool, right? That's what these routing protocols do and allow us to be able to do. So that router 1 now knows what to do with these when it needs to route something as well. And it should show you all the physically connected ones as well. And if you go to router 2, you should be able to see these networks right here as well. Okay, so let's tweak a few things like bandwidth and everything else. So if we go to our interface, our serial interface, you can just change bandwidth, just like you do with the HRP. Change it to 128, I believe is what your does. Now, you need to do this on both ends. So if I go to router 2, that serial connection that's connected to it, let's be set up the same, right? Let's see if we can see what we got here. Static cost. Okay, look at this. Yeah, here's the cost number that we have. Do show. And here we can see the bandwidth. So if you do the show interface, should be able to see the bandwidth right here. And here's where you can see the cost. And we could change the cost here. So to get to this 12 network, that's a higher cost, but do that serial connection, right? This is a quicker connection. It is a virtual connection and loop back, so it should be quicker. All right, let's change that cost. Okay, I'm gonna go back to router 1. So we're gonna change the bandwidth. Should be pretty straightforward. You've already done this before, right? Changing the bandwidth. So it shouldn't be anything too new. We will change the cost. So I'm going to go to interface serial. You go into the interface to change the cost. So I'm going to go to the interface, OSPF cost. I'm going to change this to a really high number. And then let's see and verify And there you go. That's how you verify that you changed the cost, right? Or you can change it to whatever you want, right? So now we've made this really low priority, right, of routing. So just some of the things you can manipulate, all this is to show you is that you can manipulate some aspects of OSPF just like you can with EIGRP. And there's other aspects you can change, just like with the EIGRP. We didn't dive into it as well with that. But these are really cool protocols to use. And that is how you do it. And those are your labs, guys. You're going to get pretty familiar with OSPF. And like I said, it's going to be a big part of your final. So I'm going to stop the recording now.